Hi, I'm Ms. Boom. Let's look at the remainder theorem and how we use it in factorizing polynomials. Factorizing. Why do we factorize quadratics? Usually we do so to solve or find the x-axis intercepts. And so we can ask a similar question, why do we factorize polynomials? And again, we can similarly answer that by saying that we can solve and find the x-axis intercepts. Previously, we've seen in long division that we had a dividend, a divisor, the quotient, and a remainder. And it took us quite a while to do long division to find this pattern. Is there a faster way to find the remainder? Now we notice that if we let the divisor equal to 0 and bring all the numbers across, that if we substitute this x equals 2 into our polynomial or our dividend, then what do you think we'll obtain? Now if we substitute the 2 into our dividend and put that through, so 2 squared plus 7 times 2 plus 11, we're going to get 29. And what is 29? That is our remainder. So quick recap, if you let the divisor equal to 0 and you plug that number into the dividend, we're going to get the remainder. Divisor value into the dividend, obtain remainder. We can rewrite this equation by multiplying everything by x minus 2, such that now we have x minus 2 over here times the quotient, and then the x minus 2 times x minus 2 cancels out to be 29. Now we can repeat this sentence using symbols. So p of x, our dividend, equals x minus a, where a is our 2 over there, the quotient, and the remainder. And instead of writing remainder, this time we can write p of a. So let's try another example. Here I've used the CAS to solve for it, and let's see if it works and we obtain minus 12 as our remainder. So how do we find the remainder? By putting p of the negative 2, because we let that equal to 0 and x is now negative 2. So p of negative 2 is negative 2 cubed plus minus 2 and minus 2, which gives us minus 12, the remainder. So what is the remainder theorem? The remainder theorem is when p of x is divided by beta x plus alpha, then the remainder is p of negative alpha over beta. This sounds a little bit more confusing, but if you look back here, so when we have x plus 2, the remainder, you can work it out by doing p of negative 2. So when you have x plus alpha, p of minus alpha will give you the remainder. In this example, beta was 1 and alpha was 2. So minus 2 over 1. Let's do another example to see that again. So there's our theorem. I've just placed it up there so we can see it. Use the remainder theorem to find the value of the remainder and CAS to check your answers. So here we have a polynomial and it's divided by 2x plus 1. So let 2x plus 1 equal 0. We can see that x is equal to minus a half. So we're going to plug that into the equation and that would give us the remainder, which is 4. So now we're going to try the CAS. So if you tap in action and then transformation and then factors and prop frac, and you put that dividend in brackets, divided, and then brackets the divisor, you will obtain that, which is the quotient is x squared and the remainder is 4, like we expected. One more, let's see if you can try it. Pause the video and give it a go and unpause to see the answers. So what is the number that you plugged in to find the remainder? So x plus 3, let it equal to 0. The number that you plugged in was minus 3. So putting minus 3 in that equation would give us minus 63. And you can try using the CAS again to see if you're correct. Example 5, when p of x, which is equal to 2x cubed minus x squared plus x plus a is divided by x plus 3, the remainder is 6. Find the value of a. Recall that when we started polynomials in our first video, we did something very similar. First, we substituted and found values, and then the last, or close to the last question, part of the question had A, and then you knew what the value was, and you work backwards to find A. So that's exactly what we're doing here. So now we can see that that is divided by x plus 3, or in other words, our value we're going to plug in, our polynomial, is minus 3. So when we sub in minus 3, we should get the remainder, and then it's stated that the remainder is 6. So 6 is equal to that with x substituted as minus 3. So 6 is equal to all of that with x as minus 3. So when we simplify that, we obtain A equals to 72. So give that one a go again. It's a little bit confusing because we're working kind of backwards to find what A is, and we're given the remainder. And don't forget what the remainder theorem is. So whenever you divide a polynomial by a dividend, let the dividend equals to 0, and whatever that value is, if you substitute it back into the dividend, you're going to obtain the remainder. Thank you for watching, and I'll see you next time. Bye!